This is the tutorial on identifying solid figures and lateral and surface area of prisms and cylinders. Let's begin by identifying what cylinders and prisms are. On the left here are a couple examples of your typical cylinder, and on the right, your typical prism. Now you can tell with the prisms that they're a little bit more complicated than your typical cylinder. All cylinders look the same, they look more or less like a soda can. However, prisms can come in all different shapes and sizes. For example, this top figure is a rectangular prism. It's made up of all right angles, and it's created by two rectangles, as you can see by the congruent sides. Next, we have an isosceles trapezoid prism. You can see that it's a trapezoid, and you can see that it's isosceles by the congruent sides right here and here. We also have a pentagonal prism. Down here in the bottom, it's a five-sided three-dimensional figure. You can have all sorts of prisms. You can have hexagonal prisms, octagonal prisms, triangular prisms. You'll see some more examples as we go on further. One important aspect of prisms is the number of vertices, edges, and faces that a prism has. And we can use something called Eulers Formula to verify that we're actually dealing with a prism by counting up these vertices, edges, and faces. Now, Eulers Formula is written here, that the number of vertices minus the number of edges plus the number of faces on any prism has to equal 2. And we'll verify that in a moment so that you can be sure that you're dealing with prisms. Let's take a look at these two examples in order to verify Euler's formula. We can do that by solving for the number of faces, edges, and vertices of each polyhedron. Let's begin by double-checking what a vertice, edge, and face is. Now, you should know your vertices as anywhere where two lines meet and they make an angle. So here is a vertice, and it's any two or more lines. So you can see that 3 come together in that particular vertice. The minimum that you would need is 2 lines to intersect and make an angle. Here's another vertice. Here's another vertice here. Here's one last one, and here's one more. So this particular figure, this pyramid here, which is a prism, has 5 vertices. So I'll go ahead and write our vertices down here in blue. Vertices for this figure is equal to 5. Let's take a look at this trapezoidal prism on the right. In this case, we have 1 vertice, 2, 3, 4, 5, 6, 7, 8 total vertices. So I'll go ahead and write that here as well. In this figure, there are 8 vertices. Now in a different color, I'll do it in green here, we're going to go ahead and solve for the edges of these vertices. Now an edge is essentially any segment joining two vertices. So for example, this right here would be an edge joining these two vertices. This is an edge right here. Here's a third edge. Here's a fourth edge in the back there. Then 5, 6, 7, and 8. 8 total edges for this figure. So I'm going to write edges is equal to 8. Now the figure on the right here, there's 1 edge, 2 edge, 3, 4 in the back, 5, 6, 7, 8, 9, 10, 11, and 12. So this figure has a total number of 12 edges. Now, lastly, we want to count the number of faces. And the number of faces can be added up on each of these figures. A face is any plane essentially created by a boundary of edges. For example, on the bottom of this pyramid right here, we have a face. This face is created in this square plane along the bottom. We also have one face here on this side of the pyramid, one face here on the back side of the pyramid, here's another face on the right side of the pyramid, and then here's one last face facing us. So we have a total number of 5 faces for this prism. Let's take a look at the trapezoid. We've got a face here in the back, a face on the bottom, a face over here on the side, one face on top, then we've got this forward face, and we've got this face here in the back. So we have a total of 6 faces on this figure. So we want to use this formula, Euler's formula, to verify that we're dealing with prisms. So what I'm going to do is take V, the number of vertices, so in this case on the left with our pyramid we have 5, minus E, the number of edges, which is 8, plus F, the number of faces, should be equal to 2. So 5 minus 8 is negative 3, and negative 3 plus 5 is positive 2. So 2 equals 2, we know that we're dealing with an actual prism here on the left. Let's take a look on the right. We'll take the number of vertices, 8, we'll subtract the edges, 12, and we'll add the faces, 6. And that should be equal to 2. So 8 minus 12 is negative 4, and negative 4 plus 6 is a positive 2. So again, 2 equals 2. In this case, we're dealing with an actual prism. Now, in talking about prisms, there's another formula that you should know about, and that's the formula for a right rectangular prism's diagonal. In order to calculate the length of the diagonal across a right rectangular prism, you can use the formula D is equal to the square root of the length of that prism squared plus the width of the prism squared plus the height of the prism squared. So let's go over an example. Here we have a right rectangular prism, and I've given you that it has a width of 4, a height of 2, and a length of 6. And I'd like you to calculate the diagonal of this prism. So, the length of the diagonal is equal to the square root of the length squared, so 6 squared, plus the width squared, which is 4 squared, plus the height squared, which is 2 squared. So, we have the square root of 36, which is 6 squared, plus 16, which is 4 squared, plus 4, which is 2 squared. So you want to add all those up. 16 plus 4 is 20, and 20 plus 36 is 56. And you want to take the square root of 56, which is roughly 7.5. So the diagonal of this figure would have a length of approximately 7.5 units. Alright, now I'd like to do a little work with cylinders. We'll begin by learning how to calculate the lateral area and the surface area of a right cylinder. So, the lateral area formula for a right cylinder is lateral area is equal to 2 times pi times the radius of the cylinder's circles times the height of that cylinder. And the surface area formula is that surface area is equal to the lateral area plus 2 times the area of the base of the cylinder. So let's take a look at a cylinder and I'll show you what we're referring to. In this case, the radius of this cylinder is 5 centimeters down here at the bottom. And it's got a height of 15 centimeters here along the side. So we can begin by calculating the lateral area of this cylinder. We know that the lateral area is equal to 2 times pi times the radius times the height. So, in our case, we've got our 2 pi, we've got a radius of 5, and we've got a height of 15 centimeters. So, we can do 2 times 5 is 10, and 10 times 15 is 150. So we have a lateral area of 150 pi units squared. I'm going to leave our answer in pi because it's more exact. However, you could multiply it out, 150 times the average value of pi, 3.14, and go ahead and solve for it that way. If you did, you'd get an answer of 471.2 units squared. Now let's take a look at our surface area. In dealing with surface area, we want to use the lateral area that we just calculated plus 2 times the area of the base. Now, in a cylinder, the base is the circular ends. I'll go ahead and shade those in here in blue. These two are the bases of our cylinder. The difference between lateral area and surface area is that the lateral area of a cylinder is just the circular part of the cylinder that connects the two bases. So in this case, it's just this white area all the way around the cylinder. So if you can imagine the cylinder in 3 dimensions, it's that whole outside area. Like on a tin can for a soup can, that would be where the label is of that soup can, all that area, but not including the top circle and bottom circle of that soup can. Whereas when you're dealing with the surface area, it's not only the lateral area, the area around the can, it's also the area on top of the can here, and on bottom of the can here. So the surface area is always going to be greater than the lateral area on a cylinder. So the area of the two bases can be calculated by using the area of a circle formula, which is area of a circle is equal to pi times radius squared. So that's what we want to calculate here. We want to calculate the area of one of these base circles. They're both identical, so when we know one, we can just multiply it by 2 to have both of them, which is where that 2 comes from right here in the formula. So the area of the bottom base, let's calculate that. The area of that circle is equal to pi times its radius, which is 5, squared. So the area of our circle is 25 pi. So, to calculate the surface area of this right cylinder, surface area is equal to our lateral area, which is 150 pi units squared, plus 2 times the area of the base. And the area of the base was 25 pi. So we have 150 pi plus 2 times 25 pi, which is 50 pi. So the total surface area of this cylinder is equal to 200 pi.